Hello everyone. In this video we're going to talk about absolute value inequalities. So absolute value inequalities. Absolute value inequalities are extremely important in higher level math. In particular, they come up a lot in like an advanced calculus class. So if you decide to study mathematics as a major, this type of math is really useful. Okay, so there are two properties, okay, and for both properties, we're going to let A be a positive number, okay. So the first property is the following. It says if the absolute value of x is less than A. So what does that mean? Well, the absolute value of x is the distance between x and 0. So we're saying that x is a number whose distance from 0 is smaller than A. So let's draw a picture, see if we can reason the result. So x is a number whose distance from 0 is less than A. So where could x be? Well, it could be over here, it could be here, it could be here, it could be here. It could be any of these places, right? If x is a number whose distance from 0 is less than A, it can be anywhere over here in this yellow region. And we have a less than, so that means we have a parentheses. So x is somewhere in this interval. So that means x is less than A and it's greater than negative A. So that's intuitively how we get this result. So whenever you have a less than, just memorize it. Less than, 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 less than. 2. If the absolute value of x is greater than A. So again, let's draw a picture and try to reason our result. So here is A, and here is negative A. So we're saying that x is a number whose distance from 0 is greater than A. So that means x is over here somewhere possibly, because if it's bigger than A, it can be over here in this yellow region, or it could be over here, right? If the distance is bigger than A, it's one of these numbers. And we have a greater than symbol, there's no equal to part. So it's parentheses. So that means x could be over here. In that case, x is bigger than A. Or it could be over here. So in this case, x is less than negative A. So again, let me just go through the reasoning one more time. So in this case here, x is a number whose distance from 0 is smaller than A. So x must be between negative A and A. In this case here, x is a number whose distance from 0 is bigger than A. That means x must be over here, which is bigger than A, or over here, which is smaller than negative A. So how do you memorize it? Well, the way I memorize it is as follows. Whenever you have something like this, it's less than. So it's less than, less than, less than. So just less than, bring down the 2, and then just put a minus here. So if you had this, same thing. Or let's do less than or equal to, same thing. It'd be less than, I'm not saying the equal to, I'm supposed to, 4, and then negative 4. So less than, less than, less than, less than, less than, less than. What about the greater than? Well, if you have something like this, here's a really cool trick I made up. So this is greater than, right? Greater, or, right? Greater. See, if you say it like this, like a dinosaur, you'll see the or. That's not how you spell it, but it works. So greater than 2, and then you flip it and put a minus. Let's go ahead and do some examples. So less than, and then greater than. That's fun to do. All right, let's solve some of these. Solve. Let's do 2 parentheses x minus 1 less than 6. So this one is a less than. So before we drop the absolute value, we should always isolate the absolute value. So we divide by 2. So you get the absolute value of x minus 1. And then 6 over 2 is 3. And this one is less than. So less than, less than, less than. So x minus 1 less than, less than. It's fun. And then here you have the 3. And then you just put the opposite sign here, right? So less than, less than, less than. Then you add 1 to all the sides, right? Because you're trying to find x. These go away. Negative 3 plus 1 is negative 2. Less than x, less than 4. And then the answer here, The answer here is all the numbers between -2 and 4. So from here, you can go straight to the answer. It's always just parentheses, -2, comma 4. Always, every single time. Just boom, boom, no matter what. All right, let's do one with an OR. Let's see. Solve. Absolute value, x plus 2, greater than 6. Correct, greater than 6. So solution. So this one, we've already solved for the absolute value, so we're ready to like use the formula, okay? So whenever there's a greater than sign, you drop the absolute, whenever you have the absolute value by itself and there's a greater than sign, you can drop the absolute value, so x plus 2, greater, or is the or, and then it's x plus 2, and then it's less than the opposite, okay? So you just put a less than and you switch the sign. Okay, it takes some effort to learn this stuff. So this is probably one of the harder things. Then subtract 2. So you get greater than 4. Or you don't have to keep writing the or, but I wrote it again for fun. Then minus 2 less than -8. Now, whenever you have the or, you're going to get a union every single time. So it's not necessary, but I like to draw a picture. And then you just plot these numbers. Okay, so 4 is here. And -8 is here. Okay, so whenever you have the or, whenever you have the greater or than, you're going to get an or, and you're always going to get a union in the answer. So let's see. So greater than 4, that's all the numbers over here. Less than -8, that's all the numbers over here. So and we have a strict inequality, right? There's no equal to, so it's parentheses. If it was like this or like this, we would have brackets and stuff, right? We would have the little bracket thingies. So the answer comes from the picture. So it'd be all of these numbers over here. So -infinity to -8, union 4 to infinity. So again, whenever you have a less than, it's less than, less than, less than. Whenever you have a greater than, there's an or, and you're always going to get a union. In the videos that follow, you'll have more examples. I hope that made sense.